Artificial intelligence looks weightless. It lives inside software, inside algorithms, inside digital conversations. But there is a physical place where artificial intelligence actually happens. A building, a data center. Inside these enormous facilities are thousands of servers, thousands of processors, networks, storage, cooling systems, and one resource without which none of it works: electricity. The world is building artificial intelligence at extraordinary speed, but beneath that digital revolution, a physical infrastructure race is beginning, because every new AI model needs compute, every new AI service needs servers, and every server needs power. The next bottleneck in artificial intelligence may therefore not be intelligence at all. It may be electricity. The digital economy has always depended on physical infrastructure, but artificial intelligence is increasing that dependency. Every AI model requires computation. Every computation requires machines, and those machines consume electricity. According to the International Energy Agency, data centers consumed around 415 terawatt-hours of electricity globally in 2024. Its base case outlook projected that demand could approach 945 terawatt-hours by 2030. That is not simply a technology story, it is an energy story. Because behind every request made to an AI system, there is a physical machine somewhere doing the work, and that machine has to be powered. Here is the problem. You can build a better AI model tomorrow. You can release new software tonight. You can deploy an application across the internet almost instantly. But you cannot create electricity infrastructure that quickly. You cannot instantly build a transmission line. You cannot manufacture every transformer overnight. And you cannot simply connect unlimited demand to an existing grid. The digital world moves at software speed. The physical world moves at construction speed. And artificial intelligence is beginning to collide with that difference. A data center is not simply a warehouse full of computers. It is an integrated industrial system. Servers process information. Specialized accelerators perform AI workloads. Networking equipment moves data. Cooling systems remove heat. Power systems regulate electricity. Backup systems protect operations. Fiber networks connect the facility to the outside world. Every subsystem matters, and every subsystem creates another dependency. This is why a data center is better understood as infrastructure, not simply as a building. Then comes another problem: heat. Every computation consumes energy, and that energy eventually becomes heat. The more computational hardware you place inside a facility, the more difficult it becomes to remove that heat. AI accelerators increase computational density. Higher density creates greater thermal challenges. Cooling, therefore, becomes part of computational capacity. If you cannot remove the heat, you cannot keep the machines running. And if you cannot run the machines, you cannot provide the AI. AI is therefore creating a new infrastructure race. More models require more compute. More compute requires more data centers. More data centers require more electricity. More electricity requires more infrastructure. And infrastructure requires capital. The chain keeps expanding. This is why the AI boom cannot be measured only by software revenue.
Look beneath the applications. Look beneath the algorithms. There is an enormous industrial system being built to support them, and that system is becoming an economy of its own.
And now the economic architecture becomes visible. Data centers require land, buildings, servers, cooling, networking, power systems, and electricity. All of these require capital. The IEA reported that capital expenditure by 5 major technology companies exceeded $400 billion in 2025 and was expected to increase further in 2026, driven largely by data center investment. This tells us something important. The AI boom is not only creating software companies, it is creating infrastructure demand. And wherever infrastructure demand accelerates, capital follows. If electricity matters, location matters. A data center cannot simply exist anywhere. It needs reliable power. It needs connectivity. It needs suitable land. It needs cooling. It needs infrastructure. And increasingly, it needs access to additional electricity capacity. This changes the geography of technology. The most valuable locations for the AI economy may not simply be where software companies are headquartered. They may be where electricity, land, networks, and industrial infrastructure converge. The map of artificial intelligence is becoming partly a map of energy. And this is where infrastructure becomes economics. When a resource becomes scarce, its strategic value can increase. When an infrastructure layer becomes difficult to replace, the companies capable of providing it can gain leverage. We saw this with chips. Now we can see the same principle with power, grid access, cooling, data center capacity, connectivity, land. Each layer can become a bottleneck, and whenever a bottleneck becomes critical, dependency grows, and dependency can become leverage. So, if you want to understand where artificial intelligence is going, do not only follow the algorithms, follow the chips, follow the data centers, follow the cooling systems, follow the transmission lines, follow the capital. Because the visible AI economy sits on top of an enormous physical foundation, and every foundation has bottlenecks. Every bottleneck creates dependency, and every dependency creates the possibility of leverage. That is the hidden architecture. AI is not floating in the cloud. It is sitting on top of factories, power grids, data centers, networks, and capital. The chip was only the beginning, because once intelligence becomes infrastructure, the next question is, who controls the network connecting everything? ASUTSEN, architecting wealth, automating future.